Hey guys, this is Mr. C, and in this video we're going to talk about some rational exponents and how to simplify expressions with rational exponents. So first thing I need to tell you is when you see an expression and it has variables and it has exponents that are fractions, the properties of exponents we already talked about in our last video will still hold true. So you still have a product of powers, quotient of powers, power of power, power of a product, power of a quotient, zero exponent, and negative exponent. All these properties are still true. It's just that m and n in each of these is going to be a fraction instead of a whole number, which is fine, or an integer. So we can still handle them all the same way. And so I'll refer back to that little graphic organizer if I need to. First thing is when you see two of these bases side by side and it's multiplied, then you take the two exponents and you have to add them together. And so really this is going to be 1/2 plus 2/3. So we need to add those two fractions together, and we need to kind of do this quickly. So if you choose the butterfly method, you do 3 times 1, which is 3, plus 2 times 2, which is 4, over 3 times 2, which is 6. And so if you use this method, 4 plus 3 is 7 over 6. And so your exponent is going to be 7 over 6. And you still have to have the base of x to the 7 over 6. So a lot of students will just write 7 over 6 because they think, oh, well, I just need to add the fractions and that's my answer. If you don't put the base down there, the whole thing is wrong. So make sure you put the base on there also along with the exponent. Okay, next one is the same thing. You've got two bases side by side, so you're going to add the exponents together. So we need to do 6 over 5 plus 1 over 2. All right, so without doing the butterfly this time, I'm going to talk through it. 6 times 2 is 12. Plus 5 times 1 is 5, over 5 times 2 is 10. 12 plus 5 is 17. And so your exponent turns out to be 17 over 10. So my final answer would be x to the 17 over 10. All right, here we have another one. 3/4 and 7/2. This one, you could either use the butterfly method or you could just change the 7/2 into 14 over 4. That might be easier. So 3/4 plus, and you can get a common denominator right now. You could just write 14 over 4, just multiply them both by 2. And now 14 plus 3 is 17. And now you get 17 over 4, even easier than the butterfly method in this case. And so your final answer is x to the 17 over 4 for that one. For this one, you can't really do that because you got a 4 and a 3, so you're probably going to need to use a butterfly method. So bases side by side, so you add. So 9 over 4 plus 4 over 3. All right, 9 times 3 is 27, plus 4 times 4 is 16, over 4 times 3 is 12. And by the way, the butterfly method is based on the fact that if you do get a common denominator and multiply each of these like this, 3 over 3 and 4 over 4, because their common denominator would be 12, right? 4 times 3 is 12. You're still going to get the same thing as this because here's your 27 and here's your 16. And then there's your 12 and there's your 12. So the butterfly method is just a quick way of dealing with that. You'd have to do it anyway. 27 and 16 make 43. And so we have 43 over 12 for our exponent. Final answer, x to the 43 over 12. All right, so here we have an integer times a fraction, or an integer and a fraction. So the two bases are side by side with multiplication. So we're going to do 3 over 1 plus 5 over 7. All right, 7 times 3 is 21, plus 1 times 5 is 5, over 1 times 7 is 7. And then 21 and 5 make 26. There's our exponent. So x to the 26 over 7 for that one. So the rule for when the bases are side by side, which is product of powers, is the same as it was before for integer exponents. It's just that you have fractions now. So what about when you have a quotient? Well, this rule is still going to be the same. You're going to take the two exponents and you're going to subtract them. And so now we need 4/3 minus 1/2. All right, so when you subtract, you can still do the butterfly method. You just have to be careful because this fraction is bigger than this one. And so my answer has to be positive, since the bigger number comes first and you're subtracting a smaller number from it. So my answer has to be positive. If you do the butterfly method, you just have to make sure that you don't do the negative with this, you do it with the second one. So what I'm going to do is, instead of doing the butterfly method, I'm going to actually, in this case, get a common denominator, and I'm going to add the fractions, well, I'm going to subtract the fractions, getting that common denominator. So 3 times 2 is 6 would be my common denominator. So I need to multiply this one by 2 over 2 and multiply this one by 3 over 3. And I don't mind doing this every so often. 4 times 2 is 8 over 2 times 3 is 6 minus 3 times 1 is 3 over 2 times 3 is 6. Now I have a common denominator, and 8 minus 3 is 5. And so my exponent turns out to be 5 over 6. And so x to the 5 over 6 is my final answer for that one. All right, here's another one, a lot like that. Again, this is just practice. So again, we have a quotient of powers, so we need to subtract the exponents. So we need to do 3/4, and then we need to subtract 1/6 from it. All right, common denominator in this case would be 12, because 4 times 3 is 12, and 6 times 2 is 12. So I need to multiply this one by 3 over 3, and this one by 2 over 2 to get 12 under both of those fractions. All right, so now I have 9 over 12 minus 2 over 12. 9 take away 2 is 7. And so our exponent is going to be 7 over 12. And so x to the 7 over 12 would be our final answer for that one. Okay, here we have another one. This one is 4 here and a 3/2, so we need to subtract again. So we need 4 over 1 minus 3 over 2. Okay, so this one, our common denominator is going to be 2. So all I need to do is multiply this guy by 2 over 2. I don't need to multiply the second one by anything. All right, so I got 8 over 2 minus 3 over 2. 8 take away 3 is 5. So my exponent is going to be 5/2. And so x to the 5/2 is my final answer for that one. Okay, this time I have an exponent of 1 with that x down there. So we're looking at 6/5 minus 1. I can take that 1 and turn it into 5/5, no problem. So 6/5 minus 5/5, because that's equal to 1. 6 minus 5 is 1, and 1/5 is going to be my exponent this time. So that one's pretty easy. So x to the 1/5 should do it for that one. Okay, this example, again, we have a 6 here and a 4 here, so we got 1/6 minus 7/4. This is interesting because I'm going to be subtracting a bigger number, which means my result here is probably going to be negative. So let's see how this works. Common denominator of 6 and 4 is 12. So I'm going to multiply this by 2 over 2 and this one by 3 over 3. We did this before. Okay, so now I should get 12s in the denominators. So 2 over 12 minus 21 over 12. Okay, 2 take away 21 is going to be a negative 19 over 12. That's my exponent. So when I subtract these, I get x to the negative 19 over 12. Now you're always going to want to write your answer with a positive exponent. So now what you have to do is you have to now take your negative exponent rule, remember this one, and that's your flipper. And so I'm going to write a flipper on here just to remind us. And it's going to take that x to the negative 19 over 12, it's going to flip it into 1 over x to the positive 19 over 12, just like it did with the integer exponents. So don't forget to do that if you have a negative exponent, even if it's a fraction. You still have to flip it. All right, looks like this is going to happen again the same way because 2/3 is smaller than 3. So 2/3 minus 3 over 1 My common denominator is going to be 3. So this one already has it. This one doesn't. So I have to multiply by 3 over 3 to get it. Okay, so now I have 2/3 minus 3 times 3 is 9 over 3. 2 take away 9 is negative 7 over 3. And it is negative. So x to the negative 7 over 3. Again, it's a negative exponent. I have to flip it into 1 over x to the positive 7 over 3. And now I have it. All right, so that pretty much does it for that rule. And now we have some that look like this, and this is a power of a power. So when you have a power of a power, you take the two exponents just like you did before, and you're going to multiply them. So when we multiply these, we're really going to get 6 over 5 times 1 over 3. Okay, so let's say I don't know any better about simplifying right here. 6 times 1 is 6, and 5 times 3 is 15. So 6 over 15 looks pretty good, but I can also divide both these numbers by 3. And if I divide them both by 3, I'm going to get 2 over 5. And it's better to have that reduced fraction as my answer. So x to the 2 over 5 would be my final answer for that one. Okay, so here we have another one. Again, power of a power, so we multiply. 3/4 times 2 over 1. 3 times 2 is 6 over 4. And that can be reduced down if we divide them both by 2. That can be reduced down to 3 over 2. And so my final answer would be x to the 3 over 2. Always make sure you have your base there. Don't forget that. All right, here we have another one. We're going to multiply 3 over 2 times 4 over 3 because we're using our power of a power rule. Again, I don't want to confuse you by simplifying this here. We'll simplify it at the end. 4 times 3 is 12. 3 times 2 is 6. Okay, 12 divided by 6, we all know is 2. So that one's pretty easy. And my final answer would be x squared. All right, here's another one. We have 5 over 4 times 2 over 5 because it's a power of a power. 5 times 2 is 10. 4 times 5 is 20. And 10 divided by 20, actually, if you divide by 10 for both of them, would reduce down to 1 over 2. And so our final answer is x to the 1/2. All right, let's try this one. All right, we're going to multiply 4 times 1/2. So 4 over 1 times 1 over 2. 4 times 1 is 4. 2 times 1 is 2. And 4 divided by 2 is just 2. So our final answer is x squared. We already had one like that, but it's a little bit different. Okay, this one. Again, power of a power, so we're going to multiply. So we have 9/2 times 4/3. Okay, 9 times 4 is 36. 3 times 2 is 6. And it turns out that 36 divided by 6 is exactly 6. And so this whole thing is x to the 6th. And you see these a lot on the EOC too, where they simplify like that. A lot of times they do, and sometimes they don't. But this one's simplified nicely. All right, so let's talk about some negative exponents. Again, if you have a negative exponent, it's a flipper. And so we need to take this and write it as 1 over x to the positive 1/4, like that. Not a problem there. Okay, so now we have our product of powers rule, but we have a negative number here. So we have 2 plus a negative 3/4, right? Because you add them together. And so I can even put that in parentheses if I want to. But a negative and a positive just make a negative. And so we really have 2 minus 3/4. Okay, so that's really 2 over 1 minus 3 over 4. So now we have to get a common denominator. So 4 would be our common denominator. So we're going to multiply this guy by 4 over 4. We'll leave that one alone because it already has a 4 down in the denominator. 8 over 4 minus 3 over 4. 8 take away 3 is 5. and it's looking like 5/4 is going to be my exponent. So x to the 5/4 is going to be my final answer for that one. Okay, so here we have negative 2/3 and 7/2. So we're going to add those together. Negative 2/3 plus 7/2. You could switch the order and you could write 7/2 minus 2/3. It doesn't matter. We can deal with it like this. We need a common denominator, and 3 times 2 is 6. So we need to multiply this guy by 2/2 and this guy by 3/3. All right, when we do that, we're going to get negative 4/6 plus 7 times 3 is 21/6. All right, so we have a negative 4 plus 21, and that's going to combine to give me a positive 17/6. That's going to be my exponent. So x to the 17/6 is going to be it. Okay, so here we're going to subtract. So we have 5/2 minus a negative 1/3. Notice I used parentheses. I did that because these two negatives are going to cancel out, and it's going to actually make a positive. 5/2 plus 1/3. This is going to move up here anyways and be positive anyway. So that makes complete sense that that's going to happen. Need a common denominator. 3 and 2 again is 6. So 3/3, 2/2. I guess 6 is a pretty common denominator. 15/6 plus 2/6. 15 plus 2 is 17. So it's looking like 17/6 again. Interesting. So my final answer is x to the positive 17/6. So it looks pretty good. And let's see. Negative 1/3. Just make sure I did that right. 15. Yep, that looks pretty good. All right. Next one. I've got this one right here. Okay, now I've got two negatives. When this happens, probably what you might want to do is, like we saw before, these two guys are going to switch places. You can switch places, no problem. If you do that, your life is probably going to be a lot easier than if you try and subtract a negative from a negative. Now, you could do that. You could subtract a negative from a negative, or you could switch them and they're both positive. You're still going to have to subtract. So let's suppose we just left it like this and we just follow the rule. If we do that, we're going to get negative 1/4 minus a negative 7/2. Now we can deal with this, no problem. These two negatives are going to make a positive. So we have negative 1/4 plus 7/2. Common denominator is going to be 4. So I need to multiply this guy by 2/2. Okay, so if I do that, I'm going to get negative 1/4 plus 7 times 2 is 14/4. A negative 1 and 14 makes 13. And so now I'm going to get a 13/4 for my exponent. And it is positive, so I'm good. And so now I'm going to write my answer as x to the 13/4. No problem there. Let's take a look again at this here. And this one has a couple things going on. I have multiplication and then I have some division going on. So I'm going to deal with this first and then I'm going to take care of this. So let's do this first. I need 4/3 plus 2/1. Okay, common denominator is going to be 3. So I need to multiply this one by 3/3. So now I get 4/3 plus 6/3, which is actually going to give me 10/3. Okay, so all of this turns into 10/3. So now what I'm looking at is, and I'll write it over here, x to the 10/3 still divided by x to the 3/2. Okay, so all of this up here turned into that. Okay, so now I'm going to actually subtract the two exponents. So I like to do my scratch work over here on the right, so I'm going to do this now. 10/3 now, I have to take away 3/2. Okay, so I need a common denominator again. Again, it's 6. So times 2/2 over here, and times 3/3 over here. All right, so let's see how this works out. 10 times 2 is 20. So I have 20/6 minus 3 times 3 is 9. 9/6. 20 take away 9 is 11. And for my final answer, it's going to be x to the 11/6. All right, guys, that about does it for some rational exponents. Remember to like my video and subscribe to my channel if you haven't already, and we'll see you guys later. Bye.